And we're back in still better than ever, and we're still working through empirical formulas. We are now on example number 7, and if you want to pause the podcast and actually try example number 7 and example number 8, and then restart it up so that you can double check your answers, that would be just fine. Okay? And now that I see that you're not actually pausing this thing and not trying it on your own, I'll just go ahead and give you the answers anyway. Alright, so here we go. Determine the empirical formula for a compound that is 62.1% carbon, 13.8% hydrogen, and 24.1% nitrogen. So instead of writing down the percentages, I think we all now know that we can assume that these percentages are going to be the masses in grams if we simply assume that we have a 100-gram sample. So I'm just going to start right away now with 62.1 grams of carbon, 13.8 grams of hydrogen, and 24.1 grams of nitrogen. Okay? And so, again, trying to find the lowest whole number mole ratio, we're going to change all of the masses into moles by dividing by the molar masses. So there's the molar mass of carbon. We would do the same thing with hydrogen, and we would do the same thing with nitrogen. All right? And when we perform those calculations, we have 62.1 divided by 12.01 for the carbon, and I'm getting 5.171 moles of carbon. Do the same thing with the hydrogen, 13.8 divided by 1.008, and I'm getting 13.69 moles of hydrogen. And then with the nitrogen, 24.1 divided by 14.01, excuse me, I'm getting 1.720 moles of nitrogen. Now, to find the lowest whole number mole ratio, we're going to divide through by the lowest value, so we're going to divide them through by the 1.720 since that is the lowest one. This will be a 1. If I take the 13.69 divided by the 1.72, I'm getting 7.96. And if I take the 5.171 divided by the 1.720, I'm getting 3.01. So effectively, though these aren't perfect numbers, this is approximately 3, this is approximately 8, and this is still 1. Now, how close does it have to be? Well, for our purposes, it's either going to be right smack in the middle, like a 3.5 or a 7.5 or something like that, or it's going to be right on the money, and so we can assume that this is going to be a 3 to 8 to 1. So the empirical formula will be C3H8N1. Okay, of course you don't have to write the 1, so it'll simply be C3H8N. And there you go. That would be the empirical formula for that particular compound. Now, example number 8. Once again, if you want to pause and give this one a shot, feel free. If not, away we go. The empirical formula for a compound that is 42.87% carbon, 3.5898% hydrogen, 28.55% oxygen, and 25% nitrogen. So we have 4 elements in this case. It's exactly the same as before. We assume that we have a 100-gram sample, so therefore we have 42.87 grams of carbon. We have 3.598 grams of hydrogen, 28.55 grams of oxygen, and 25 grams of nitrogen. You got to get it into moles. Why? Because it's a mole ratio. That's what an empirical formula is. So we're going to divide through by the molar masses again. 1 mole on top, the 12.01 grams on the bottom. The grams divide out. We're left with moles of carbon. Do the same thing for the hydrogen. Grams divide out. 1 mole of oxygen has a mass of 16.00 grams. And again, if we're going too quick, make sure that you pause and then try to catch up. So notice we've changed all of the grams of the substances into moles. Let's just go ahead and do the calculations now. 42.87 divided by 12.01 gives me 3.57 moles of carbon. 3.598 divided by 1.008 is going to give me 3.57 moles of hydrogen. The 28.55 divided by 16 is giving me 1.78 moles of oxygen, and the 25 divided by 14.01 is giving me 1.78 moles of nitrogen. So now simply divide through by the lowest term, which is going to be the 1.78. So we divide through by 1.78, 1.78, 1.78, and 1.78, and of course these bottom two are going to be ones, and the 3.57 divided by the 1.78, it's going to be approximately 2, it won't be exact. It's actually 2.01, and so that's close enough for 2, or to 2. And so our empirical formula will simply be C2H2O1, of course drop the 1, N1, and so it's C2H2OM. Alright, so make sure you practice those, try them on your homework. The first step, or one of the first steps to determining the composition of a compound, or the actual formula of the compound, is to determine that empirical formula, and we've shown you that in 4 straight examples. In the next set of podcasts, or the next one podcast, we're going to show you how we can determine molecular formulas from those empirical formulas. We'll see you next time.